Algebra 2, 6.3 Day 1, Perform Function Operations. So let f and g be any two functions. A new function h can be defined by performing any of the four basic operations on f and g. So addition, subtraction, multiplication, or division. So in our example, f of x is 5x and g of x is x plus 2. So if we're going to add these functions together, we get that h of x equals f of x, which is 5x, plus g of x, which is x plus 2. 5x plus x combines to be 6x and 2. We get 6x plus 2. Now if we subtract our functions, h of x equals f of x, which is 5x, minus g of x, which is x plus 2. 5x minus x is 4x minus 2, because our negative here distributes. Okay? Multiplication, h of x equals 5x times x plus 2. 5x times x is 5x squared. 5x times 2 is 10x. And for h of x equals f of x over g of x for division, we get 5x over x plus 2. We cannot cancel these out because there's this addition here, so we're done. So far, you have studied several types of functions, including linear functions, quadratic functions, and polynomial functions of a higher degree. Another common type of function is a power function, which has the form ax to the b, where a is a real number and b is a rational number. Example, let f of x equals 4x to the 1/2 and g of x equal negative 9x to the 1/2. Find the following: f plus g. So we're going to take 4x to the 1/2 plus negative 9x to the 1/2. We have x to the 1/2 here, x to the 1/2 here, so we can combine those. 4 minus 9 is negative 5. And then we keep our x to the 1/2. So there's our answer there. Now if we do f minus g, we do 4x to the 1/2 minus a negative 9x to the 1/2. Again, we have x to the 1/2 here and x to the 1/2 here. Our minus and negative can change to a plus. And we get 4 plus 9 is 13, x to the 1/2. Okay, the domains of f plus g and f minus g. Well, first thing we have to look at is there a restriction on either of these? So, the domain of f, the domain of g, and then f plus g and f minus g. This is what we're going to find for this one. Okay, so if you remember, a 1/2 exponent means that it is a square root. We cannot take the square root of a negative number, but we can for 0 and a positive number. So that means x has to be greater than or equal to 0. Anything positive works and 0 works. Same for g. So we get x is greater than or equal to 0. And then f plus g gives us the same thing, and f minus g gives us the same thing. Okay, so if we have a square root where n is even, x has to be greater than or equal to 0. if we have a fraction, we cannot divide by 0. I think that'll come up a little bit later in the notes here. Nope, maybe a different day. So, example 2, let f of x equal 6x and g of x, keep missing that g, equals x to the 3/4. Find the following. F of x times g of x would be 6x times x to the 3/4. We have a product of powers here. This one has an exponent of 1. 1 is the same as 4/4. And then we add because it's a product of powers. So we get 6x to the 7/4. And here we're dividing. So 6x over x to the 3/4. So now we have a quotient of powers. So 6 stays, and we have x to the 1 minus 3/4. 1 is the same as 4/4. So we get 6 times x to the 1/4. Okay, now we have to find the domains of f and g, and then f times g and f over g. Okay, the domain of f. 6x, we can plug anything positive, negative, 0 in there and it'll give us an answer. So this one is all real numbers. Okay, this one is a 4th root. So n is even, so we have to have positive numbers in there, or 0. So x has to be greater than or equal to 0. Now, this one, we multiplied them, so we have to use any restrictions from over here. So this one comes over to here. And then we see if there's any more to add. And there is not. So it's just x is greater than or equal to 0. Now this one also comes over here. This one would too, but there's no restrictions. But we have an extra one now. We have a fraction here. And we cannot divide by 0. So whenever x is 0 here, we're dividing by 0, and that doesn't work. So for this one, it is just x is greater than 0. Not x is greater than or equal to 0. Okay, so for example 3, for a white rhino, heart rate R in beats per minute and the lifespan S in minutes are related to body mass M in kilograms by these functions, this one and this one. Find R of M times S of M. So we are going to do 241 M to the negative 0.25 times 6 times 10 to the 6th M to the 0.2. So we're going to do our numbers times each other. So 241 times 6 times 10 to the 6th ends up being 1.346 times 10 to the 9th. And then this is bigger than this, so when we add them, we get m to the negative 0.05. Negative means we put it in the bottom of a fraction. So this is our answer here. Now, this product is the beats per minute and the lifespan in minutes. When we multiply those together, the minutes cancel. We're just left with beats. So this product represents the number of heartbeats a rhino has during its lifetime based on its mass.